Static few-shot examples waste tokens and miss edge cases. Semantic selection retrieves the most relevant demonstrations from FAISS for each new query. You'll walk away with a setup that selects the most relevant examples for each query while staying within a prompt budget. I'm Professor Pine, teaching AI engineering and LLM systems with simple Python. Most teams start by copying a handful of hand-picked demos into every prompt. That looks simple, until token bills climb and the examples don't match the current request. Dynamic few-shot selection answers a clear question. Which demonstrations actually help this particular query right now? The trick is straightforward. Store short example tasks as searchable vectors, then pick the nearest demonstrations for each new query. A sales question pulls SQL-like demos. A tone edit pulls tone examples. And the model keeps the context that matters most. We will build a tiny demo that formats one example, embeds examples into FAISS, finds similar examples, then filters those candidates to respect a prompt budget. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we create the smallest reusable example unit, so later parts have something to retrieve. This snippet produces the minimal LangChain prompt unit for a single few-shot example, so you can see exactly how one demo will appear in a prompt. It keeps each demo small and structured, an ID, task, and answer, and uses prompt_template.fromTemplate to define the display. Calling examplePrompt.format shows the formatted demo, so you can confirm the shape before any retrieval happens. Separating formatting from selection makes later comparisons clear. The selector can change which examples are chosen without changing how they look on screen. The visible output prints the one formatted demo, which becomes the reusable display layer for the rest of the tutorial. That formatted demo looks fine, but we need a way to search across many of them quickly. This example builds a searchable LangChain FAISS index from the demonstration tasks, so we can find close matches automatically. HuggingFaceEmbeddings turns each task into a vector, and face.fromTexts stores those vectors with a small ID as metadata. Similarity search with score then asks FAISS for the nearest task, and the print focuses on the chosen identifier rather than raw distance numbers. The visible output shows which stored demo is closest. That nearest neighbor lookup is the retrieval primitive behind dynamic few-shot selection. Nearest neighbor retrieval is great, but we still need a selection policy that plugs into prompts. This code swaps manual picking for LangChain SemanticSimilarityExampleSelector, so the system chooses demos for you based on similarity. SemanticSimilarityExampleSelector from examples wires up the examples, the embedding object, and the FAISS index, while input keys equals task ensures it matches on the user-facing task text instead of answer wording. Calling select examples returns the example dicts you should place into the prompt. Increasing K brings in more demonstrations and uses more context. Lowering K keeps the prompt compact but less varied. The visible output prints the selected demo ID, which makes the selector's behavior easy to log across runs. Selecting nearest examples can still blow the token budget unless we control prompt size. This snippet adds a simple, practical budget step after LangChain retrieves candidates, so the prompt doesn't grow unchecked. We pull a slightly larger pool with k equals 3 to give the selector options. Then format each candidate with example prompt and estimate its size with a quick word count. Only the formatted examples that fit inside the budget get appended. That word count is a lightweight proxy for a tokenizer. So in production, swap in the tokenizer that matches your model. The visible output shows how many candidates were retrieved versus how many were kept. That kept count is the metric you want to track when comparing prompt runs. Now, we wire selection and budget into a repeatable prompting path to run actual requests. This example turns the FAISS-backed selection flow into a tiny LangChain prompting baseline so you can run experiments consistently. The experiment path is: call run task, retrieve candidates with wide selector.select examples, apply the same budget filter, and pass the surviving examples into few-shot prompt template. Prefix, example prompt, and suffix make the final prompt layout explicit, which lets you store and diff prompt text between runs. The loop is small on purpose. It keeps selection and budget decisions visible, instead of hiding them inside a larger chain. The visible output shows the final demo count and the rendered prompt size, both useful fields for run tracking. In a production system, this maps directly to user workflows. Run the selector per incoming query. Use the model tokenizer to estimate tokens, and log which example IDs were used for auditing and A/B testing. What this is: a pipeline that finds the most semantically relevant demos and keeps only those that fit your prompt budget. Use it when fixed examples cost tokens or fail to cover diverse queries, especially for user-facing assistants or test suites. One caveat: coarse word counts are only a proxy for tokens and can mislead, so use the model tokenizer in production. Tune FAISS retrieval depth and token budgeting next. Specifically, increase FAISS nprobe to trade recall for latency, and switch the budget estimator to the target model tokenizer to measure real prompt token usage. If practical AI engineering helps, subscribe and watch the AI engineering videos.